Bash. Shell scripting for the command line. Agenda. Shell scripting systems. Bash history. Why Bash? Bash script. Lifecycle. Getting started. Basic workflow. Write, permit, and run. Shell scripting. Shell scripting automates a sequence of commands you would otherwise type into a terminal by hand. If a step fails partway through, you can fix the script and rerun it from a known repeatable state. Almost every server, build pipeline, and CI job relies on shell scripts somewhere. Any team automating operations tasks ends up writing bash scripts. Repeating the same manual commands by hand every day doesn't scale. Interactive shell and scripted automation. An interactive shell runs commands one at a time, typed directly by a person at a prompt. A bash script bundles many commands into a single repeatable version-controlled file. Interactive, typed at a bash prompt, one command at a time, nothing saved for later. Scripted, deploy.sh, backup.sh, install.sh. Problems without scripting, single point of failure. A step is forgotten because someone typed it from memory. No repeatability. The same task run twice by two people rarely looks identical. Slower for routine work, since every command is typed by hand each time. Hard to share a process except as a wiki page of verbal instructions. Difficult to test a sequence of commands safely before running it for real. Misses out on version control, code review, and automated scheduling. Bash scripting system. A script's commands are written in a plain text file and kept in a source or Git repository. The interpreter path is declared on the first line with a shebang such as hash exclamation mark bin bash. Bash reads and executes the file top to bottom, just like commands typed at prompt. Other similar shells, ZSH, DASH, and fish FSH. Bash advantages runs on nearly every Linux, macOS, and WSL Windows Subsystem for Linux environment with nothing extra to install. Speeds up repetitive tasks by turning many manual steps into one command. Uses minimal resources, no runtime or virtual machine required. Makes automation simple and consistent across servers and environments. Combines cleanly with standard Unix tools like grep, sed, and awk. Integrates naturally with cron, systemd, and CI/CD pipelines. Everything is text, almost. One huge benefit is that almost everything a script touches is plain text, files, output, configuration. Commands can be piped together, letting small tools combine into powerful pipelines. Exit codes make it easy to check whether a previous command succeeded or failed. Scripts are easy to read, diff, and review since they are just text files. A script's logic and behavior travel with the file. Nothing is hidden in a compiled binary. Variables and conditionals. Variables store a value once and reuse it anywhere later in the script. Conditionals branch a script's logic based on the result of a test. Deploy.sh. A typical script declares its interpreter, the first line, stops on errors, and runs a sequence of commands. Backup.sh. Here a function loops over a list of directories and archives each one. History. Written by Brian Fox in 1989 for the GNU project as a free replacement for the Bourne shell. The name is Born Again shell, referencing both its predecessor and its open source rebirth. Became the default login shell on most Linux distributions throughout the 1990s and 2000s. Apple shipped Bash as the default macOS shell for over a decade before switching to ZSH in 2019. Still, the most common shell for scripting servers, containers, and CI pipelines today. Why Bash? Ubiquity. Pre-installed on nearly every Linux, macOS, and Unix-like system. Simplicity. No compiler, build step, or extra runtime needed. Composability. Small commands pipe together into powerful one-liners. Transparent. Scripts are plain text you can read, edit, and audit. Huge ecosystem, decades of tools, tutorials, and community answers. Free and open source. Maintained as part of the GNU project. The shebang line. The shebang line hash exclamation sign with bash must be the very first line of the script file. Tells the operating system which interpreter should run the rest of the file. Requires the script be marked executable with chmod plus x before it can run this way. Change the mod plus x for executable. Never leave a blank line or comment above the shebang. It must be line 1. Bash script lifecycle. Nanoscript.sh write chmod plus x script.sh make executable dot slash script.sh execute echo dollar question mark exit code printing. A script is written, made executable, run from the shell, and finally leaves behind an exit code that reports success or failure. Getting started with Bash. This leads us to the three things every script needs to run. Shebang declares which interpreter should run the script. Permission marks the file as executable. Execution runs the script from the current directory. Basic workflow. Author a file with some automation in mind. Give the necessary permission. Practice and implement. Writing, permitting, and running. Some call write chmod and run bash everyday loop. Fast. Scripts start executing immediately with no compilation step. Encourages small, focused scripts that each do one thing well. Set EO pipe fail catches errors early instead of silently continuing. Scripts can be scheduled with cron or triggered by CI/CD pipelines. Supports many workflows, deployment, backup, log rotation, provisioning. Works the same across every Linux server, container, and CI runner. Any questions? Thank you.